Okay, well, welcome to the talk. I'm going to give you a little bit of an update on Groovy, the Groovy 4 mostly. There's a tiny bit on Groovy 3, just to anyone who's still catching up. Let's get started. I'm Paul King. Been involved in Groovy for quite a long time now, and certainly get in touch with me if there's anything you need to know that I don't get time to cover today. So Groovy, most of you who are in this track are probably very familiar with Groovy. Multifaceted programming language. It's known for having both static and dynamic natures, so it can be like Java, Kotlin, Scala if it wants to be, or it can be like Python if it wants to be. And very extensible, very good for domain-specific language support, and it's got some scripting capabilities and whatnot. We'll dive in and get into some details, and we'll see examples of some of these things. So what's the state of play? The world's in a not a too good state at this time, perhaps, but Groovy is in pretty good shape. So it's still pretty healthy. We've passed a few milestones. We've gone over the 1,000 contributors, and the code base is continuing to grow, and things are looking healthy. We're in the final stages of getting Groovy 4 ready for GA release. We've got a few release candidates to go and a bit of polishing, and then Groovy 4 will be out. Certainly by the end of the year, if not a little bit earlier than that. Downloads, again, one of the milestones we passed was going past 1 billion downloads earlier this year. So the downloads just keep increasing. So there's a lot of people, if not using Groovy, it certainly seems very popular, but there's certainly lots of people downloading it. And we've had, of that 1 billion downloads, 500 million of that has been the last 12 months. So it's as popular as it's ever been. Great news. And they're only the numbers that we know about, which is a small subset of all the numbers. How does it rank in terms of the rankings? It's hovering just outside the top 10. It seems to jump around 10, 11, 12. Sometimes jumps up a little bit more. It's been in that roughly that same position for a little while now. It's sort of hovering around, breaking into the top 10. Never seems to stay there for long when it does, but it's in good shape. So the JVM is a great place to be. Java's obviously at the top of that index there. It's in position 2 in the graph I've captured there earlier this year. It's now at 3, and Python is edging its way towards number 1, but it's still very, very healthy. It's not going anywhere, and certainly the top 3 are a big jump up from most of the others in terms of the overall rankings. So Java's in a healthy spot. The fact that Python is in a healthy spot is also good for Groovy, because Groovy is sort of the Python of the JVM world. So that's all great. As I said, the JVM is a great place to be. We've got Kotlin, Scala, and Clojure also in the sort of top, in the 30 to 50 sort of range as well. So there's lots of good languages if you're on the JVM to go and pick from. What happened in Groovy 3? I haven't really got time to go into lots of the details. Groovy 3 was when we introduced the Parrot parser. A lot of work Daniel Sun did to get that in shape. This sort of all set the groundwork for Groovy 4. So we've got a new parser that's more flexible to work with. We did our normal range of extra enhancements for the GDK. That's sort of the enhancement that we make to Java to make Java a little friendlier to use, more productive to use. And we added some more AST transforms, because they're our compile time metaprogramming way of capturing design patterns and idioms in a very, very compacted, collaborative way, make programmers very productive. And we did a bunch of other work setting the ground for where we're taking Groovy 4. We started off doing a lot of things to prepare for the Java module system, split package remediation, which I'll come back to, improved annotations, some YAML support, and so on. Groovy 4, we go a step further. Again, there's a whole lot of bells and whistles, which are the latter 4 main bullet points or main subsections in this slide, and a little bit of consolidation and structuring. So there's lots of new shiny things that'll make it more productive and more pleasant as you're programming in Groovy. But we've managed to make the zip about a third smaller, and the core jar is about 10% smaller. So you get all these extra things, and it's all smaller. And that's due to some consolidation that I'm going to talk about in a minute. In fact, we'll talk about that first. Some structuring and consolidation. So most of this, some of you won't be interested in this at all. It's all sort of a sideways shift so that we get things in good shape. You'll be interested in the bells and whistles. We'll get onto those next. Okay, so the first thing is consolidation and structuring. Let me just get something going. Okay, the Maven coordinates have changed. So if you're going and looking for the Groovy artifacts in your favorite binary repository, or maybe you've got a corporate repository, they'll be stored under org Apache Groovy now instead of org Codehouse Groovy. Now, just some people have thought that meant we also went and changed all the package names. We haven't gone and done a wholesale change of package names. We've been changing all package names as we create new classes inside Groovy. Over time, we've just been making that change, and that's all seamless to you most of the time. So this is just all about just the Maven coordinates, and package names are just changing behind the scenes across versions, and we'll continue to do so. Some module changes. There's a few modules that aren't in widespread use. Groovy BSF, the bean scripting framework. Most people use the JavaScripting JSR 332, whatever it is. And Groovy Jaxby 223. Groovy Jaxby we only had a few little bells and whistles there, which hardly anyone used, and it was the way Java's packaged these days. It was more of a nuisance than useful to anyone to have those there. So we've removed those in Groovy 4. You can still go grab the jar out of Groovy 3 if you really need those capabilities. There's 5 new modules, and we'll come back and talk about those. And there's a slight tweaking in which modules are in the Groovy all jar. TestNG is our least used of all the jars that used to be in Groovy all, so we've made that optional now. A lot of people are using JUnit, particularly JUnit 5. It works very, very well with Groovy, so a lot of people are using that. Still, some people like TestNG, so you can still go grab it if you want to. And Groovy YAML was the most widespread of all, most widely used of all the optional modules. So we now include that in Groovy all. So you'll get that. You can exclude that if you don't want it, but you'll get that for free. Now, I mentioned split packaging remediation. We started this in Groovy 3. So what's all this about? One of the requirements of the Java module system is that all the package names inside a module are unique, basically. So we used to have a Groovy XML jar and a Groovy core jar, and we had the same package name, groovy.util, in both of those. And so in Groovy 2.5, we've got Groovy util XML parser, for instance. What we did for Groovy 3 was we made it so you could avoid all of those potentially conflicting package names if you want. So we made a Groovy XML parser version of that class. They're essentially identical classes, 2 copies under 2 different package names. So the idea is for your entire lifetime of using Groovy 3, we're anticipating you'll be migrating away from the Groovy util versions over to the Groovy XML versions. Groovy 4, you've only got the Groovy XML versions to play with. So that allows us to be fully compliant with all the Java packaging requirements. And even though Groovy 4 is we're not fully using module info yet, we're in a very good place where we can now turn that on at any time we want. One of the things we introduced with Groovy 3 that I mentioned previously was the Parrot parser, the brand new parser. We had a switch. You could go and turn the old parser on just in case anyone had any problems. They could go and revert to the old one. We haven't had any feedback saying people had to go back to the old one for any issues in terms of parsing code. So we've now removed that. We have had feedback that people would like the Antler 4 parser to be more efficient. So we're still working on that, but that'll be an evolving story. We're working on that as we can. One of the things we also did quite a few versions many years ago, back in JDK 7 times, they introduced the invoke dynamic bytecode instructions, which offer some ways for dynamic languages in particular, and all languages, to do certain kinds of operations in a more efficient way. And when we first started using that, we found very early versions of the JDK 7 invoke dynamic bytecodes were a bit flaky. And because we'd highly optimized the traditional way of doing these things, when we first converted over, some sections were less efficient using Indy. So we kept both around. We've now done quite a bit more work trying to optimize that all our Indy code. So we don't think there's any cases now where you wouldn't want to be using Indy code. So we've removed all the classic code, and it's all invoke dynamic all the way. Now, there are just a couple of places where we still fall back to the classic bytecode. It's there for backwards compatibility. If you've got some classes compiled under early versions of Groovy, they'll still run, no problems there. And there's a few places where our new generation code calls back into the old code. That's all transparent to users. And over time, we'll get rid of those little bits that remain. Okay, language features. So these are the things that people will be really keen to see, because you'll be using this to make yourself more productive, do some nice things. We'll dive down and look at each of these sections here. First cab off the rank is records. So Daniel's been working hard on, we've had a record type AST transform for a little while now. Daniel's gone and done a little bit more work to get the grammar working with that, and so it's pretty much there. We'll be doing a little bit more polishing before we do the final release, but it's in good shape. So it's a shorthand for writing data classes, so DTOs, immutable DTOs in particular. So you can go record point, and you can have 3 properties, and you declare all those properties in line as much as you would parameters of a method or a constructor. You just put them in line. And this is similar to, so Kotlin and Scala have similar ways to shorthands for writing these sorts of classes. So Java's just introduced that in 16 and 17 with a preview a little bit, 14, 15, wherever it started. We now support the same syntax and generate the same sort of things. I'll dive into a bit more about that a little bit later. But basically all the things, if you go and read up any Java tutorial on records, things about implicitly final class, certain features of how the properties, the backing fields are, the accessor methods, all of that's identical to the Java story here. So anyway, it's a nice terse way of writing a data class. And we'll come back to that later. Sealed is the next feature that's also appeared in the latest JDK 17. And again, it's been previewed for a little bit before that as well. And it's all about having a little bit more control over inheritance. So inheritance is very powerful abstraction for building systems. Here I've got a class shape, and I've got square and circle as subclasses of shape. And that can be useful. I can have common code in the shape class that squares and circles might use. So it's a way of structuring my code across that inheritance hierarchy. Now, there are scenarios where limiting the inheritance has benefits. Okay, and we've got ways of doing that. We can make a class final, and that stops all inheritance. But in many languages that only have that, so we've got full inheritance or no inheritance. It's a very much a all or nothing proposition. And there's a lot of scenarios where you'd actually like some sort of controlled inheritance. And we've got various tweaks that we can use. We can have things like package private parent classes and a bunch of things that allow us to have a little bit more control, but it's not as powerful a feature as having proper sealed classes. Other languages have had friend classes and similar things. So it's not an uncommon idea. It's now in Java, and we've now got support for that as well. So basically, it's you provide a fixed set of children, okay, and it decouples accessibility from extendability. So we had little tricks that we could use in Java to mimic some kinds of control over our inheritance hierarchies, but the two were tied together. I couldn't access some sort of base class without also making it extendable for other people to access it by extension. So we've got now 2 options. We can make sealed hierarchies and we can have unsealed types in those hierarchies. If you're using the sealed approach, then you get classes where it's easy to add new methods. You know all of the classes in the hierarchy, so you can add a new method and easily write the code in that method that knows how to deal with all of the classes in the hierarchy. It's harder to add new types. Unsealed types, so that's sort of the status quo. It's easy to add new types. I've got a shape type. I can just go and start creating triangles, squares, diamonds, whatever I want. If I add a new method, then I have to go back and rework a whole bunch of classes in that sort of scenario. So you can judge when you might want to switch between those. Again, urge you just go and look at the Java tutorials on sealed classes, or Kotlin, or Scala, or C# or some of the other languages that support this sort of thing. You'll get some good motivation for why you'd want this. Want to get through this pretty quickly. There's 3 examples here. One showing the base type being a class, one as a trait, one as an interface. They're all supported as you'd expect. There's 2 different syntaxes. One's using a sort of, the bottom 2 are using the keyword sealed, and the top one is using an annotation sealed. You can use either syntax. We actually rely on the top syntax for stashing away the sealed information if you're using an earlier JDK. So it's a way for us to support this on versions of the JDK prior to JDK 17. So they're just the examples there. Now you can also, my mouse keeps going to sleep. These are good for writing algebraic data types or abstract data types. So here I've got a tree sealed interface. And I forgot to mention something on the previous slide. The first one mentions the permitted subclass in a list in the annotation attribute to the sealed annotation. The second example lists the 2 permitted subclasses using the permits clause. Okay, equilateral and isosceles. The bottom one doesn't mention what the permitted subclasses are. So if you're in the same class file, source file, then it'll automatically work out what all the permitted subclasses are. And that's what the bottom one's relying on. So this example is also relying on that. And I've used the @sealed notation here because it just ties in with what I've done for the other nodes, but I could easily use the keyword there as well. And here I'm using a singleton, I'm using a canonical, I could use other things. Creating a tree of nodes, and so my empty instance is a singleton, and I'm creating that tree up, and I can create some sort of expression for a node of integers there. Okay, you can have hybrid hierarchies. Now, what do I mean by that? I've got both sealed and non-sealed and final classes in the mix here. So that's the code, but let me show you a sort of pictorial that might be easier to sense. Shape is my base class, and it's a class here. It could be an interface or a trait. Here it's in the code that we showed you before. It was a class. It's controlled because I've got sealed. It can only have 3 things. They're circle, polygon, and rectangle. They're the 3 things that it can have. Circle is a final class, so inheritance stops at that point. Polygon, we've gone and marked it as non-sealed. And what that means is open slather. At that point, we allow any extension. In the code we've supplied, we've only got Pentagon, but in general, there might be other people might come along later and also extend Polygon. And so any code inside Polygon might need to be defensive and guard against that possibility. So it might want to, if you have a switch expression, instead of having just 3 things, circle, polygon, rectangle, that's appropriate at the shape level. Inside Polygon, I might want to have a default clause and say, found an unknown shape. I don't know how to print this shape or whatever it might be. The third part, the third branch of my little inheritance hierarchy here is also orange in this picture here. That's also sealed, and there's only one thing underneath it that happens to be a final class. So you can have 3 options there. That's showing you all the different options. So that's what they are there. Very slight difference between Java and Groovy. You can leave out non-sealed, and you'll get a non-sealed class, which is the default. Java's wanting you not to mistakenly leave yourself in that position. The whole point of having these hierarchies is you know exactly where everything is. Opening something up means you don't know what all the different classes might be, which is appropriate, as I said before, in some scenarios and not appropriate in other scenarios, depending if you're trying to add methods or types. And so we're following the Scala practice there of leaving out non-sealed gives you a non-sealed. And we envisage down the track, we might have a code narc rule that would let you enforce that. If you want to stick with Java style in your Groovy, is maybe you're doing Java and Groovy, then if you want to stick to that style, we envisage a code narc rule so you could enforce that as a style issue rather than a requirement of the compiler. Next thing I want to talk about is language integrated query. We might see it references GQ or GINQ, Groovy integrated query. It's the whole idea is to have a language level support for writing SQL-like expressions across aggregations. So I'm not necessarily talking to a database here. In fact, we're not supporting databases at this point in time. We're supporting lots of other traditional collections. So you can parse a JSON file, you can have in-memory, normal lists and maps and all that sort of stuff. And you can use these queries across that. So let's have a look at what that might mean. Some motivation. Let's look at the map filter reduce way of interacting with a list of people. So here I've got a record person who happens to have a string name and an int age. I've got 3 such person objects in my people list. And what I'm going to do is I'm going to use the normal map filter reduce. So I've got people.findAll, put in a clause there, .sort by age, do a collect. I'm going to project to just the name and the age fields out of those person records there. That's the traditional way of doing things, and that all works fine, and we're not changing any of that. I could use the lambda syntax instead of the groovy closure syntax there. That's all still fine as well. But if you're more familiar with SQL style, as I said, Groovy gets used by a whole bunch of different people. Some are coders, some are sort of data scientists doing scripting or whatever they might be. They might be more familiar with interacting with SQL engines where you feed in a query. So you can do the same expression from P in people where P.age, order by, select, and that'll achieve the same result. So you can just decide which of those 2 styles you prefer. And it's fairly feature rich. This is just a few examples here. There's showing different things. There's projections, filtering, joins, aggregation, sorting, grouping, and so on. So all the things you'd expect to have in this kind of API are all supported. And just so you understand how this is all working, basically this is mapping back to an API. So you could go and use the API directly if you want. But the whole point of this syntax is to give you this friendly syntax that you can go use. And there we are. So this is showing records. Again, this one happens to be on JDK 11. I could have been using JDK 8. And here I'm using records, language integration query. I could be using seal types, and all of that would work nicely out of the box there. So we're doing that same query, doing it all that I showed you before inside the Groovy shell. Switch expressions, they let you, so in the past we've had switch statements where you had bits of code and different branches, different case branches, and you might have had case something and a colon, and then maybe one or more statements, and often a break, and maybe a return, sometimes fall through. So that was the limit to what you could do. It never returned a value. It just executed things in a certain order. And you could do things like using returns or setting variables or whatever it is to achieve something. Now a switch becomes, instead of being a switch statement, it's a switch expression, so it can return a value. So here I've got result equals the switch, and I'm passing in an integer. And given various cases, it will return various single character strings there, and we're doing an assertion. So that's what switch expressions are all about. You'd expect so Groovy's got a very powerful switch statement, and it can have things like arrange. So I can have Monday ... Friday. I can have lists, Sunday and Saturday. I can have classes. I can have regex expressions. I can have closures. All of those things are supported even with switch expressions. So all the things you might expect to have, they'll all be there. And the colon version is still also supported. you'll need to use yields typically in that scenario to get your results back. So here I've got case Monday to Friday, yield false. So this is it the weekend? Maybe I should make long weekends, change that to Monday to Thursday and have Friday, Saturday, Sunday. But I guess this is all pre-COVID times when we used to work at an office and used to attend somewhere and had the weekends off, whereas now it's all 24/7 or something. It seems to be sometimes. Anyway, that's switch expressions. Type annotations have been improved. So back in various past Groovy 2 versions and Groovy 3, we've been adding additional annotation support in more places. So we've had existing support is annotations on parameters, as well as annotations on, you can have them on, you can see the grab is on the import statement. You've got an annotation on the method, the property. The for all, the size, and the unique elements are all parameters to the A-list parameter. But the int range is actually a type annotation on the generic integer type of the list. So you've got a list of integer, and we're saying that, in fact, those integers should all be between 0 and 10. And in fact, when I run, this is using jQuick, which is a really nice property-based testing framework. It'll go and run 1,000 tests or whatever it is, passing in unique elements of lists of size 5, all with numbers between 0 and 10. So that's a really nice feature, and it's just we've gone and added additional support. So that's all been hooked in place. This is the Java bean validation framework. So again, a fair chunk of this was already supported, but if I had a list of non-blank strings that wasn't supported, that's now supported now. Okay, some libraries and tooling have also been improved. There's some built-in type checkers, built-in macro methods. Let's dive in and we'll cover each of those. So this is a little bit of code. I've got a New Year's Eve from last year, 2020-12-31. I'm going to try to parse that with regex. So I'm going to have a group of 4 digits followed by a hyphen, and then a group of 1 or 2 digits followed by a hyphen. And then I'm meant to have a group of 1 or 2 digits at the end, but I'm missing the closing round bracket, if you can see that. So what happens when I run this code in Java or the Java equivalent, or if I run this in Groovy, I'll get a runtime exception. So a pattern syntax exception. Ditto if I was using the pattern and matching capability in Java, I'd get the feedback at runtime. So even though Java's a statically typed language, the parameters inside the regex packages are untyped strings. So if we go use the regex checker, and I'm showing this in the sort of laborious full way of doing it, but you can actually hide the details. I'm going to just check for these regex things just on one method. So on that one method, I'm going to say, go apply the regex checker type checker extension. So Groovy's static typing is extensible, and this is an optional checker. And you can go and apply that everywhere if you want, or in this case here, we're going to apply it just on one method. So it won't happen automatically normally. If you want to, you can force it to happen. Here, we're just going to make it happen just on one method. And now when you compile that code, you'll get that feedback. And you get that feedback not just on the Groovy shorthands, the sort of regex type shorthands. If you go use the pattern.compile in any of the Java APIs behind this, you'll get the same sort of feedback. And similarly for groupings, I've got 3 groups in that date. If I ask for the 4th group or the 5th group, it'll tell me that's a non-existent group if I've got a constant in my APIs, and it can detect that sort of stuff. So it can give you more feedback at compile time. Built-in macros. So if you ever do sort of poor man's debugging, so if you haven't got a debugger to hand, you might sort of do some print lines or something, and you print out the name of a variable and its value. Here's some little built-in macros that do all of that for you. So you can do print line NV, and give it a list of variables, and it'll print out the names of the variables and their values. And there's a few different variations. There's one that just calls toString, one that calls the .inspect, and one that calls dump. So you can use whichever version of those that you want. You'll get slightly different looking values. We expect to have more of those type checkers and more macro methods maybe in Groovy 4, maybe in future versions of Groovy. So Groovy 3 had this YAML builder and slurper. It was popular. TOML is becoming popular as an alternative format for storing configuration information. So we've got an optional builder and slurper for TOML as well. I'll let you look at the doco if you want more details. We've got a JavaShell. So Groovy Shell is, so even though Groovy is a very flexible language, we allow you to use a Groovy Shell, which fires up a brand new Groovy environment and lets you compile stuff. And you can tweak that environment. And it's really, really handy for working with snippets of code. We find it useful to also work with snippets of Java code. So we can have snippets of Java code, snippets of Groovy code. And what I might do is check that a record created by Java and a record created by Groovy are similar. They might have the same properties, the same methods, the same whatever. I can do a whole bunch of things by using JavaShell and Groovy Shell and compile up different variations. So I might have some sort of for loop that's trying a whole bunch of different, I might try primitive integers, full integers. I might try a whole bunch of different things and see that we get the same values out. Here I'm also enabling, I'm on JDK 14 and I'm enabling preview as part of setting up this little Java shell. So it's a little environment for working with Java snippets. So I can go and create a Java record in preview mode inside my Groovy and then print it out, and I've got a little toString there of the class that I created and using in Groovy and checking its value. And we hook that up inside the Groovy console as well. So instead of compiling your code as Groovy, you can compile it as Java and run it as Java. So you can decide which of those you want. Just because it's often handy to be able to switch between the two and see what you get. And it was easy to hook in, so we added it. Ranges have been extended. So we've always had this idea of inclusive ranges, so 1 up to and including 5. And we had this exclusive, so 1 up to but not including 5. Well, now, instead of calling that exclusive, is now right exclusive or open on the right. And we can have open on the left or open on full exclusive, open on both sides. So all of those are supported. Okay. Just going to briefly mention some AST transforms. So what are AST transforms? So this is Groovy's compile time metaprogram capability. So when Groovy's compiling up this book class on the slide there, it's got some properties. So Groovy goes and adds getters and setters. Compile time metaprogramming lets you tweak that compilation process. So have some input. I wanted something slightly different. So what I can say is, yeah, give me an automatic toString that factors in my author's title and publication date properties. Make it automatically print out all of those. And it'll go and generate the same class as before, but now with a toString, and it'll flesh that out with a appropriately crafted toString there, printing everything out. And you can go and there's a whole bunch of these AST transforms, these compile time compile time metaprogramming capabilities, and that'll give me 500 lines if I put those ones on. So it's a very powerful technique. We're capturing typical Java idioms or design patterns and capturing them in this declarative way. So it's very, very powerful. As you'd expect in each version of Groovy, even though we think we've come up with all the ones we can ever think of, some people come up with more. Groovy 4's got more. And that's the list of them there. I'm only just going to show you a couple. That's all we got time for. So Pojo is, so Groovy's got this idea of a dynamic nature and a static nature. If you put compile static on a class, it tries to make things a bit more like Java. But it still calls into the Groovy runtime in lots of places to do various things. If you put Pojo on a class, the AST transform will do its darndest to not call into the Groovy runtime at all. So it'll try to make it even more like Java. And it'll mean certain operations can't be done. I won't go into the specifics around that. We haven't got time today. But the idea is that for when it can work, I'll now get something that doesn't need the Groovy runtime jar at all. So here I've got two Groovy classes. I put Pojo on them. They're both using Groovy's compile time metaprogram. One's got canonical. The other one's using the delegate pattern. It's using a delegate AST transform. So they're both using compile time metaprogramming. I generate those classes because they're Pojos. I can now use those classes from Java without the Groovy runtime jar. And that's the code down the bottom. I won't go through the details, but it prints stuff out. So it doesn't work everywhere just yet. That's why it's incubating. We're still playing around with this, but it's kind of making Groovy into a Lombok for people who want to use it that way. We don't think every scenario is going to get covered by this, but there's some that do, and it's a useful thing to have. Showed you records before. When you have record, it gets converted into a record type annotation, which gets then, it's a meta annotation. It gets split into all these fine-grained things. So if you don't like the record definition we've given you, you can just do it a longhand and then go and tweak the bits of that you don't like. So you might get rid of you might not want the map constructor at all. We give you a map constructor over and above the normal tuple constructors. You might not want that, so you could go and prune that out and make your own variant of record. You wouldn't be able to use the compact syntax, but you could go and create your meta annotation and it would look like the second one in that list. So just on records, it's a great feature that is now from Java 16 and above out of preview. If you're interested in similar sort of functionality to bits of what records entail, immutable has been around in Groovy. It's not identical to records, but from 1.7 onwards and JDK 6 onwards. If you're interested in just the automatic toStrings and equals and hash code and what have you, there's things you can do to get that. If you're using records, you can use that from JDK 8 onwards. But if you want native records, that'll just be the normal JDK 16 onwards. So you can go and mix and match there. There's a groovy-contracts module, which is designed by Contract. This was a separate project, but it just made sense to make this an optional module in Groovy. And that way, as Groovy's evolving, we're making sure we don't go and break this particular thing. It supports design by contract. You can have a class invariance. It's a predicate that gets checked whenever anything in your class changes. You can have preconditions and postconditions on methods. They get checked prior to and after any method gets called, and so on. So if you're interested in design by contract, you can go use that. Final topic, and I'm not really going to go into any details, is GDK enhancements. As you'd expect, we've added some more in. I've just got a couple of examples. You can use there's a plus method in the stream API. You can just go use the normal plus sign, the overloaded operator in Groovy. Things like runtime.runtime.process ID. If you're on a JDK that supports that, that'll print out the process ID of the process that you're running in. They're just some examples. You can look up the full release notes if you need more details. Okay, that's pretty much all I've got time for. There's still more stuff that we're wanting to get into. We'll get to those at some point. Come and see us on the mailing list if you're interested in having that discussion. We'd love to hear from you. Okay, thanks everyone. I think my time is up. Does Groovy integrate query support all join types? It's got a whole bunch of join types. I'm not sure if that's all join types. That's the only question I can see in the chat. Can't see anything in Q&A. So there's certainly init joins, and there's a whole bunch of different joins. Look up the doco for language integration query, and you can see a whole bunch of them. There's nested stuff as well. So have a look. If there's something that you think you want that isn't there, we can certainly do that. And language integration query is extensible. So the idea is we'll cover SQL. If you're into JOOQ, we might be able to have a front end for that. That's all futures. Okay, thanks everyone.